Welcome, grade 11. We're going to look at completing the square and when we will actually be using it. So there are two different methods of working with completing the square. So let's analyze the two different methods. The one is when they say that you must work out the turning point. So for example, if I give you this equation, y is equal to x squared minus 4x minus 5. So I'm going to do two ways with this specific one. Let's say this one was equal to 0. So this is just a normal equation. And this is your function because it's y is equal. So before I'm going to do this, I also want to show you something else. And then we'll do completing the square. If I give you a parabola like this, then the first question we want to know is whether it's going to be a maximum parabola or is it going to be a minimum parabola. If it's like this, for example. So is this turning point, and to find the lowest value, or in this case, it will be the minimum value, you have to look at the value on the y-axis. So let's say the x there was 2 and the y value is -3. Then we will say this will be a minimum at -3. Let's say you sit with a parabola that looks like this. I'll go into detail just now. For example, like this. And we have a turning point at that point. Let's say it's going to be 3 and 5. Then this one will have a maximum value at 5. So you look at the y value. So this will have a maximum value at 5. So I will always say minimum is, for example, if you have a minimum amount of coffee in your mug, right? That's a coffee mug. So there's a minimum left. So this is minimum. Maximum, think of a tent. So this is the maximum height of the tent. So you must always make sure that you buy a tent with a certain height if you are tall. And if it's in turning point format, let's just write down the turning point format, x plus p squared plus q. Then P and Q will be the turning point. So this would be 2. And how do you sub it back into the equation? You change the x value. So to sub it back into the equation, you will say x minus 2. So whatever the x value is, you change the sign. So this then will be x minus 2 squared. And the y value you write down exactly as it is. So this is your P and your Q value, or the turning point. Now, working out the equation, they love asking you rewrite it in this format. So we're going to rewrite this equation, rewrite into this format. Y is equal to A, and then it's going to be x plus p squared plus q. So we're going to rewrite it in that format. So the method we use is, firstly, I'm going to write it down here. You must get the x square alone. The coefficient of x square must be alone. So get x squared alone. So we're going to, well, it's already alone, right? Because that is just a 1x. The second step we're going to do, we're going to add the coefficient. We're going to add the coefficient of x, which we will multiply by 1/2 and we square it. So it's quite a few things we're going to do. Your teacher in school normally would tell you that you're going to divide by 2. I always work with times 1/2. Divided by 2/1 is the same as multiplying by 1/2. Right, so if I look at the first one, I'm now going to add the coefficient of x. So I'm going to say x squared minus 4x minus 5. And I'm going to add now the coefficient of x, which is negative 4. And you can immediately just say divide by 2, or you can say times by half. It's for me easier when it's a fraction to know that you actually multiply by a half. Unless you always work with your calculator, then you just say divide by 2. Now, in maths, the sums must always be balanced. So if you decide to add something, you must also subtract it. But if there's an equal sign, what you add on the one side, you also add on the other side. And that's the main difference between these two type of sums when we do completing the square. Completing the square. So what you add, you must subtract again. So I'm just going to simplify this. This was negative 4 divided by 2 is negative 2 squared. The third step is when we're going to write it as a bracket squared. So now when you write it as a bracket squared, what we're going to do, we take one of these numbers because it's x squared, and you take one of these brackets because it's that one squared. So that's what you do. And you see, if you already use the whole coefficient, then you know you're going to work with a minus. Or another way of double checking the sign is always the same as the one in front of the coefficient of the x. Right, so let's make the bracket. 1x will go in here, so 1x goes in there. And inside the bracket goes here, which is negative 2. And then you square it because you took 1. So it's like rewriting it in terms of a trinomial. So if you multiply this out again, if you FOIL it, you will get x squared minus 4x. Then it's going to be plus 4, because if you work that out, it will be plus 4. Okay, I should have taken this one over, not over, but just shifted. So this is minus 5, and then we simplify this. It will be minus 4. You will understand now when we do some exercises. I owe 5 and I owe 4, so I owe 9. So this is going to be the turning point. And is it a maximum or a minimum one? Well, firstly, you look at the shape. So because there's the invisible plus, it's going to be a happy parabola. So whenever it's happy, it will have a minimum value. So this will have a minimum value. So the turning point will be positive 2 and negative 9. So it will have a minimum at negative 9. This one will be a typical question when they say solve for x. So we're going to solve for x. Now to solve for x using completing the square. Okay, we want to use completing the square. We firstly going to take over the whole number. So now the rules slightly differ. Take over the whole number. This will fall under algebra, and using this method for completing the square will fall under functions. And in grade 12, you're going to use completing the square working with circles. So quite a few uses for this. Right, so you take the whole number over. Of course, you must make sure that your x square is alone, and yes, it is. The next step, we're going to add, so it's number 2. We're going to add the coefficient of x that we multiply by half and square it. So we're going to add it. And like I said, what you add on the left side in maths, you also have to add it on the right side. Otherwise, it's not maths anymore. And as I said with the left one, if you plus, you have to minus again. The coefficient of x is -4, multiply by a half, and square it. So we add it on the left side and we add it on the right side as well. Then the next step, we're going to write it as a bracket squared. So one of these x's goes in here. The coefficient will be -2. And here you just simplify it. So we would say it's 5 plus, so you see here, it's not going to be minus because this bracket is going to become positive as well. So it's 4 divided by 2, which is 2 squared, which is 4. So this one then is going to be x minus 2 squared, which is equal to 9. Then to solve for x means get x alone. So in this case, we're going to square root both sides. So x minus 2 will be equal to plus or minus 3. So x minus 2 is equal to positive 3, or x minus 2 is equal to -3. So this is finding the x values. It's like factorizing it. So this will be 3 plus 2 is 5, or I owe 3 and I have 2, so I owe 1. That means where x is, this was a happy one, so it's going to look like this, where x is -1 and where x is 5. That's what it will look like. There's your turning point. So the turning point in this example I gave you is going to be, we'll have to work out the turning point with this one, working from there, because it's not in the turning point format. So then you must just say x is equal to minus b over 2a. Right, let's look at this. This comes from the Via Africa textbook. So the first one I basically already did. So we'll quickly redo it, and then we're going to draw it. Firstly, we're going to now say x squared minus 4x, and we're going to add. You see, so you write the -5 there at the end. So you're first going to add the coefficient of x, which you can divide by 2 or multiply by a half. And what you add, you must subtract again. Just simplify that into -2. The next step is where we're going to write one of those squares, and we're going to write one of those squares, which is -2. I owe 5 and I owe 4. Careful with the sign, and this will be squared. This then is x minus 2 squared minus 9. Then they say draw the function. So we already wrote it in that format. So what is your a value? The a is an invisible 1 there. So that is your a value. Then they say draw it. So I'm only interested now in the turning point. And they say indicate the y-intercept and the turning point. So that's all we have to work out. So the turning point is +2, you change the sign, and -9. +2 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's the turning point at 2 and -9. And they didn't say work out the x-intercepts. They only want us to get the y-intercept. So for the y-intercept, you can actually just read it off. You make your x equal to 0. So that will be 0 squared minus 4 times 0 minus 5. So the y is equal to -5. 1, 2, 3, 4, 5. So there's -5. We know it's going to be a positive one. The shape A is positive. So you just roughly draw it. Doesn't matter where it cuts the x-axis because they didn't ask for that. Indicate the y-intercept, so you must write this as 0 and -5 and indicate the turning point. Lastly, they said write down the domain and the range. So domain will be all the x values that will be applicable. If I have an x here, it will eventually touch my parabola so that we can find a coordinate. If I have an x value there, it will eventually touch my parabola so that we can have a corresponding y value. So all the x values will be applicable. So x is an element of real numbers. Or if you make use of interval notation, you say x is an element from negative infinity to positive infinity. Two methods of writing it. The range referred to the y values. So just in case you don't know all my methods, D, to remember it, D comes before R and X comes before Y in your alphabet. Can I say Y is the element of real numbers? Will all the Y values be applicable? No. If I have a Y value here or up to positive infinity, see these arrows, we will be able then to find the X value. But down here, just below -9, it will be impossible to find a Y value because -10, for example, will not touch my graph. With domain, you always look at the X values from the left to the right. But for range, you look at the values from the bottom going up. So for the range, we're going to say Y is bigger or equal to -9, because there from -9, we're going to go up for the Y values. Or you can say Y is the element and it's a solid bracket at -9. So it's -9 to positive infinity, solid bracket. Right. Next one. The first step, we're going to make sure x squared is alone, and it's already alone. Second step, we are going to add. So you write your -75 there, and we're going to add the coefficient of x that we're going to divide by 2. So it will be +10, or you can say multiply it by half, and you square it. What we add, we're also going to subtract. So I'm just going to simplify this. 10 divided by 2 is 5 squared. In the next step, we're going to write it as a bracket squared. 1x there, 10 divided by 2 is 5, and it must be a positive. So this then will be -75, and I owe 25. So it means I will owe 100. So this will be the bracket x plus 5 squared minus 100. Let's draw it. So if I draw this, turning point is going to be at -5. Remember, you change the sign. So it will be -5 and -100. The shape will be positive. And let's also get the y-intercept. So for the y-intercept, you make the x equal to 0. I'm just going to read it off. Therefore, you make all of those 0. The y is equal to -75. It's quite big value, so I'm just going to work with tens, like -10, -20, -30, -40, -50, -60, -70, -80. Turning point will be then at -5 and -100. Oh, I wrote it way too. Let's just quickly take this up a little bit, because otherwise we can't show it properly. Right. Please pause the recording and you also try and draw it and try and work it out. Don't just watch me. Okay, so this would be negative 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. The y-intercept then is negative 70, so that's 10, 20, 30, 40, 50, 60, 70, negative 80, negative 90, negative 100, negative 110. So the y-intercept then will cut there, and let's write it down because they say indicate. So you write there 0 and negative 75. Turning point is at negative 5. So 1, 2, 3, 4, 5, negative 5, and negative 100. So it's going to be approximately there. You see, you don't have to draw it accurately. It's just a drawing they want us to draw. So this is the turning point, indicated negative 5 and negative 100. And then you just randomly draw it. Okay. Always erase and have a proper turning there. That's what you do for this specific exercise in Via Africa. Then they ask us write down the domain and range. So it's just an exercise to get used to domain and range and to the turning point. The domain we said previously will be all the x values. So x is an element of real numbers, or you can say x is an element from negative infinity to positive infinity. The range, like in the previous one, we said would be the y values from negative 100 going up. So it will be where y is bigger or equal to negative 100 because, the graph has a solid line. Or if you prefer interval notation, you say y is the element, solid bracket from negative 100 to positive infinity. There you are. Next one. What do we see with this one? We must get the x square alone. That's always step number 1. Get the x square alone. So my x square is not alone. Can you just divide and get rid of it? No, you can't. You can only divide by 2 and get rid of the 2 if it was an equation with the equation being equal to 0. That's when you can do it. That's when you can divide by 2 and say 0 is equal, because then you divide by 2 on both sides. But if that's not equal to 0, you can't do it. But you must still get your x square alone. So you're just going to tag it down. So I always say write a square bracket. So now it's as if you're working with a new equation. So you divide by 2, so it will be 10 divided by 2 is 5. 18 divided by 2 is 9. And now we continue, but you must not forget that 2. So the next step is where we're going to add the coefficient that we divide by 2. So this will be plus 5x. Just put your whole number always there at the end. So we're going to add 5 divided by 2 or times a half, and we square it. And what we add, we're going to subtract again. And keep your square bracket. The next step, we're going to write it in brackets squared. Right, so you keep your square bracket. So this then will be x plus 5 over 2 squared. And this we're going to work out. So it's going to be minus 9 minus 25 over 4. So let's quickly work that out. Minus 9 and, oh dear, my calculator's in the wrong mode. So it's negative 9 you type in, and then you type in minus fraction 25 over 4. Okay, so let's first do that. So then it's going to look like this, x plus 5 over 2 squared minus 61 over 4. And the last step, you just distribute this 2 in. So it's going to be 2x plus 5 over 2 squared. And then just use your calculator. It will be 2 times 61 divided by 4. So that's going to give you 61 over 2. Right, now let's draw it. So if you look at 61 divided by 2, it's going to give you 30 and a half. So I'm just working with 30 and a half just for me so that I can have proper values when I draw it. So the first thing, indicate the y-intercept and the turning point. So just to get an idea of my numbers that I want to use, my turning point is going to be negative 2.5, right? Negative 2.5, because you work with the opposite sign there. And it's going to be negative 30.5. My y-intercept, the y-intercept, we just make x 0. So if you make the x's 0, the y-intercept is going to be negative 18. So let's draw it. This is going to be a happy parabola, positive. So the turning point is going to be at negative 2, negative 1, negative 2, and let's just mark it down in 10. So it would be negative 10, negative 20, negative 30, negative 40, negative 50. So turning point is going to be at negative 2.5, so it's approximately there, and negative 30.5. So let's just indicate it on the drawing. Negative 2, you can say negative 2,5 if you want. In the semicolon, negative 30,5. You can use any format. The y-intercept is at negative 18, so it's approximately there. And give it in coordinate format, 0 and negative 18. And then you just draw it freehand. There you are. By now, I'm sure you know how to write down your domain. Domain, x is an element of real numbers, or you can say x is an element from negative infinity to positive infinity. Range, y is bigger or equal to negative 30,5, or you can say y is the element solid bracket, negative 30,5, all the way to positive infinity. Let's look at the next one. Let's look at this one. This is the last one. Firstly, this is going to be a funny one, isn't it? Because we must divide by 3 and it's not possible. You know, it's going to be just awkward numbers. So the first thing we do is we get x squared alone. So we get x squared alone. I'm just going to keep it as g of x. And you actually divide with 3. So divide by 3, so that will be 3x minus 7 divided by 3. So don't let fractions freak you out. You just do it same old, same old. Next step, we're going to add the coefficient of x. So add the coefficient of x, multiply by half, and square it. X squared plus 3x. Please remember to keep your whole number there right at the end. Now we add the coefficient of x, which is plus 3, multiplied by a half, and square it. And what we add, we subtract again. 3 over 2 squared. and keep everything in a big bracket. If you practice this, unfortunately, you have to practice. Otherwise, we go into panic mode if we didn't practice this beforehand. Then you write it as a bracket squared. So that means you take one of those x squares and you take one of these squares. So it's plus 3 over 2. Yes, I know the teachers skip this step. They normally jump from there to there. I personally prefer to actually put in this bracket. This step is what I add. Negative 7 over 3 minus 9 over 4. Close the bracket. Right, let's work that out on the calculator. So it's minus fraction 7 over 3 and minus fraction 9 over 4. That gives me, just rewrite this first. So that's 3. And keep that square bracket until you are ready to multiply in the 3. Minus 55 over 12. And now the last step, you just distribute the 3 in. So gx will be equal to 3x plus 3 over 2 squared minus, and that will be 55 over 4. Okay, turning point will be the opposite sign there. What is the 3? The 3 will just tell you how steep this graph is going to be. So the higher this number is, the steeper, the closer the legs will go to the y-axis or the arms of the parabola. So this one will be minus 3 over 2, and the y value of the turning point is negative. Let's just convert that to a decimal. So it's 55 divided by 4, just so that we can draw it more accurately. So that gives me 13,75. Y-intercept, we read off. So the y-intercept is going to be 0 and negative 7. You just make the x's there 0. Quickly, let's draw it. So the turning point is negative 1.5. It's going to be negative 1, negative 2, negative 3, negative 1.5, and the turning point is going to be at positive 30. Oh, no, this is negative. I just thought, this must be negative 13, right? So let's read it off like in 1, 2. Let's work in twos. 2, 4, 6, 8, 10, 12, 14. And let's just get some space here so that we can draw it properly. I'm sure you do understand completing the square now. Right. So the y-intercept will be at negative 7, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. Y-intercept is then there at 0 and negative 7. Turning point, negative 1.5. So it will lie on this line. And at negative 13,75. So it's going to be here. So it's negative 3 over 2. And you can write it as negative 55 if you want to over 4. The shape is positive, so it's happy. So then you just make a rough drawing. Let's end with the domain. X is an element of real numbers, and the range y is bigger or equal to negative 55 over 4. Or you can work with x as an element from negative infinity to positive infinity, or you can say y is an element, solid bracket, negative 5 over 4 to positive infinity. Thanks for watching.